Hello, my name is DeLuryea, and this is Lab 3 for Physics 2212, Magnetic Field of a Barred Magnet. So the goal for this lab is to measure and observe the magnetic field created by a barred magnet and determine the distance dependence. Some of the fundamental principles that we will use in this lab is the Biot-Savart law and the distance dependence formula, both shown here to the right. And the results that I got from this lab were the distance dependence was negative 2.1036, and magnitude of magnetic moment was 8.1821 am squares. So the data that I got from this lab is shown here. The values above show the force of the magnetic field in relation to the distance between my phone and the bar magnet. And then this is a graph showing those data points plotted of a natural log of the magnitude in the x direction versus the log of the distance. So in order to find the distance dependence, it is just the slope of the natural log of the magnetic field magnitude equal to the natural log of k plus n natural log r. And so this resulted in a distance dependence of negative 2.1036. To calculate the magnitude of magnetic moment, first we had to take this formula that we received and do some algebraic manipulation to get k equal to u naught over 4 pi times 2u. And after doing that, you take the natural log and you get that the natural log of k is equal to negative 13.323. And then e to the negative 13.323 gives you k equal to 1.636 times 10 to the negative 6th. To find u, or the magnetic moment, we then manipulate it again and get u is equal to k over u naught over 4 pi times 2, and that gives you a u of 8.1821 am squares. The glow script for this, or the modeling for this lab, the blue arrows show the magnetic field on a perpendicular axis to the bar magnet. The orange shows the magnetic field on a parallel, and then the purple shows a 45-degree angle, and you can see the values of these in the bottom of this page. In conclusion, so what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? Well, the measurements would be off, as it would be hard to discern which field came from the bar magnet and which came from the Earth. You'd end up with a resultant vector that is different than what you're experimenting for. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? Well, now since the magnet is stronger, the magnetic field in turn would be stronger, and so that would change all of the values to account for a stronger magnetic field. Here is my glow script code, and thank you for watching.